Hello everybody, I'm Bernhard Kaiser from ANSYS, and I'm giving you a talk about the significance of a well-structured ODD specification for the AD safety and SOTIF process. To discuss how an ODD is important for a safety process, we should just clarify first what an ODD is. ODD is for operational design domain, and when I'm talking about ODD, I usually refer to the specification of an ODD, so the file format or data structure format for the ODD, which will technically serve as the input. ODD is defined as the set of specific conditions under which a given driving automation system is designed to function. In other words, I can use that automated driving function only when I'm inside the ODD. It must be disabled, and manual driving has to take place outside of the ODD. This was definition from ISO 21448. SAE J1316 specifies it in the same way, but gives a little bit more detail on examples what we could understand by an ODD. It says including but not limited to environmental, geographical, and time of day restrictions and/or the requisite presence or absence of certain traffic or roadway characteristics. The latter could refer to certain road signs, guardrails, road markings, and so on. So how could I imagine an ODD? Suppose that we have an ontology or taxonomy to find words for everything which can exist in our universe in the possible driving range. I mean, the possible driving range for a land vehicle is limited. I cannot drive on water, for instance, but I can drive on all kinds of roads, even off-road, under all weather conditions, whatever. So I can make an ontology. I have certain terms like road types and the parameters of the road, like the lane width. I have weather conditions, visibility conditions, and so on. And you could imagine this as a set of axes going in different orthogonal directions. And either the values on the axis are already enumerative. For example, road type can be highway, country road, city street, or off-road, or they are on a continuous space like the lane width. Then I can, of course, put a scale on it or can make equivalence classes. And then I use these parameters, these attributes, these dimensions of my space to delimit a green space, which is my ODD. So when I'm inside of the green cube, if you want, then I'm inside the ODD, and everything outside, so the remaining red parts are outside the ODD. So if allowed road types is highway and country road, but not city street, I'm inside the ODD for this dimension when I'm on a highway or country road, but I'm outside when I'm on a city street. So how can we represent an ODD? So most popular today are tabular notations. You see here two different examples. You can either have a table that is just reflecting the taxonomy. You have first the top attributes like drivable area type, lane, specification, and so on. Then you have sub-attributes, or finally the enum values like motorway, radial road, distributor road, or sometimes you have more numeric attributes like number of lane, lane dimensions. And here you just say yes or no if it's allowed or not. So if it's inside the ODD or outside. Another way could be tabular notation like this. You have like a checklist, the different aspects like applicable road types, speed ranges, must there be a road shoulder, must there be guardrails, may there be pedestrians, and so on. And you answer yes or no, or you put in the value ranges here. In addition to these tabular notations, there are also notations in formal languages like this. Here we have a formal language proposal for ODDs. So you have different categories, and then you have a kind of template English language like for drivable area type, we allow, and then comes selection, motorways, radial roads, distributor roads, or we do not allow minor roads. And the same for lane specification, we allow at least 2 lanes with at least 3.7 meter width, and so on. formalizing an ODD, of course, requires syntax definition. You see here to the left, it's rather an informal language. So we probably need in the future more formal languages with a syntax definition, perhaps given in a Backus-Naur form, based on an ontology. Ontology is, first of all, the terminology, the allowed words, but also how the things can be related. For example, a road has a number of lanes, and lanes have attributes like lane width. And it's important because this is edited and read by humans, that the ODD language is interpretable both for computers but also for humans. The ASM Open ODD initiative aims at defining a formal and exchangeable specification format for ODDs. So let's see how the ODD can influence the safety process, and when a solid ODD specification can be of huge benefit for a thorough safety process. This is the safety workflow that you see here according to ISO 21448, the SOTIF standard. So we have some activities outside of the safety cycle, which is specification and design, and later continuous improvement and modification. And then we have three main cycles. The upper cycle here in the dark gray box is the analysis cycle. The middle cycle in the light gray box is the verification validation for all known scenarios. And in the light blue box, in the third box, we have the verification validation to evaluate the still unknown hazardous scenarios that may exist inside the ODD. And if all of these cycles come to an end, find that the remaining risk is acceptably low, then the AD function can be released. So how can an ODD come in here? I have a couple of use cases to discuss with you. First one is, of course, the ODD provides requirements and constraints on which the AD function is developed. So it mainly addresses the development of the function itself, the yellow box here. Use case number two, hazard identification has to be carried out in a systematic manner, and to do so you need a situation catalog, and this situation catalog can be filled by the description and ontology of the ODD you are using. Then, of course, use case number three, the ODD also serves as a source for verification and validation scenario specification in the V&V cycles that you see here below. And what comes along with it is the quantitative part. Use case number four, the ODD can help establish metrics to rate the ODD coverage by V&V scenarios. When am I done with testing, if you want? Let's guide you through some of these use cases. Use case number one, the ODD as a source for requirements and constraints for development of the AD function itself. Imagine you have a simple ODD for some system saying, okay, only road type allowed is highway, the speed range is up to 120 kilometers per hour, can be any time of the day, but visibility must be at least 50 meters. Can there be pedestrians? Well, there's a sporadic occurrence of pedestrians even on the highway, but not in a regular case. I can take this for systematic requirements elicitation. Here you have a couple of sample requirements for such a system. First one is about sensor range. Short name is sensor range 150 meters. In more detail, to support highway operation at a speed up to 120 kilometers per hour, the sensor set shall be able to perceive a standard vehicle target from a distance of at least 150 meters. In the command column, you see where does it come from. The distance is calculated from the maximum speed according to the ODD definition, based on the achievable processing times in the processing chain and the brake capabilities of my vehicle. So the data from ODD, like speed, gives direction what should be the requirements of the sensor set to the ranges. And other things, we have sporadic occurrence of pedestrians. So we have one requirement here on pedestrian detection capability. We have time of day can be any. So we specify the ability to work at night, and even a specified recognition capability and distance must be ensured by the sensor set even at night, which may entail usage of some diverse sensors, for example, add an infrared camera or laser scanner on top of the regular visible light camera. And so on. Also here you see a little bit of a requirement regarding reduced visibility conditions and so on. And of course, you can also take this as assumptions, what you don't have to fulfill. So you don't have to recognize a target in a large distance if the visibility is below 50 meters, because this would be outside of your ODD. So this is a valuable input. And of course, via the requirements, it also influences the architecture and which kind of cross-checking, which kind of fusion, which sensor technologies can be in. We have here a diverse sensor set, camera, radar, LiDAR with a fusion. This is directly determined by the ODD. Let's move on to use case 2. The significance of the ODD for the HARA. HARA is for hazard analysis and risk assessment, for the HARA procedure. I cannot go in all details here, but this is a course workflow, and you clearly see here where the ODD comes in as an important starting point. From ODD, we derive a situation catalog, and from the situation catalog, we sample the scenarios for which we discuss the correct or incorrect behavior of the vehicle. If it's about SOTIF, then it's not so much about failures, but also in insufficiencies, inability to cope with certain situations. So of course, we also need the specification of the automation features, and together we form the relevant scenarios, and we formulate an expectation on the correct behavior or reaction of the vehicle in certain situations. And only after doing so, we are capable to state, okay, what else could happen instead of the expected reaction? There could be a wrong reaction, braking if there's no reason to brake, or failing to brake when there is a need to brake, or braking late, or whatever. So only this guides us to systematically identifying the inappropriate behavior or reaction of the vehicle. The rest of the process is pretty much straightforward, as in ISO 26262. We evaluate the hazardous consequences or accidents that may result. From there, we get the possible injuries, potential human intervention to prevent the accident from happening, and we can then define the hazardous event and derive our top-level safety requirements or safety goals, or some say safety constraints. I think safety constraints is even better. Along with this comes a definition of the safe state and or the minimal risk maneuver, things that I have to do when it still happens to get out of the dangerous situation, perhaps to bring the vehicle to a stop or to alert the driver if I have the time to do so, and so on. There are a couple of gray boxes that are not so much of interest here for the SOTIF domain. These are the parameters, controllability, severity, and exposure that are needed to calculate the ACL for ISO 26262. I mean, it's perfectly possible to have one integrated hazard analysis process for both FuSa and the SOTIF. But you see, at the beginning of it all comes the SOTIF, and the better the SOTIF is described, the more systematic you can do this analysis. Here we have an example of a hazard analysis table in Medini Analyze. Here you can, the left part is still coming directly from situation catalog. You see again road conditions, environment, location, and other things like vehicle speed that are not taken directly from the ODD but can be derived by partitioning from the ODD. And we see here one attribute is interesting. Boolean attribute, yes or no, are we inside of the ODD? I mean, why should we care for functions outside the ODD? Well, for SOTIF we usually don't have to, but for functional safety, for dealing with failures, we have to consider that a function interferes with steering or braking even when it should not be active by a software bug or something. So even this needs to be analyzed, and as I told you, you have to analyze specifically the case when you are unintendedly leaving the ODD while the function is on. Here we have another column for expected behaviors that help them to identify the inappropriate behavior from which the hazards are derived then. Let's move on to the third use case, ODD as a source for the SOTIF verification and validation, in particular for the specification of test scenarios or simulation scenarios to do so. We have different sources of scenarios, of course, for testing. One obvious source is the specification of the function itself. So it may be from the functional spec or from external documents like NCAP crash scenarios that may be important, for instance, for an A/B function. Then, of course, we have a recording of scenarios that happened on the real road, or even scenarios where some bad behavior was observed on the real road that you want to replay over and over in different variations. And last but not least, you may have scenarios from safety analysis. For example, you did a causal analysis, what could lead to undecided braking, and you find a couple of triggering conditions and make scenarios from these. All of this can be captured in abstract scenarios. From abstract scenarios, I can refine some more details, make it more realistic, but still with open parameter ranges. So we have the min, we have the max, but not choosing a particular speed, a particular distance, a particular visibility. This is what we call a logical scenario. And the next step is then the parameter assignment, where we create really lots, thousands, millions of concrete executable scenarios that can, for instance, be described in the Open Scenario 2 language and played on a simulation environment. So, but how is the ODD coming in here? You see we have several transformation steps, and they need different additional sources of information. Certainly for the enrichment, we need a set of building bricks of scenario fragments from which you can create all details and mixes and scenario variants. Then certainly you will need some statistics because this helps you to select the random parameters. Perhaps they are not uniformly distributed, but there are more or less frequent occurrences of parameters that are important to choose. But for both steps, enrichment and parameter assignment, you also need the ODD. Because for the enrichment, it's important because the ODD tells you what is in. What light conditions do I have to consider? What buildings, trees, whatever, road signs can be there? Can there be pedestrians? Can there be animals? Whatever. And also here for the parameter ranges, the ODD is important because from ODD definition, I learn what is the typical speed range of my ego vehicle, but also other vehicles. What are the typical lane widths? What are the typical distances between vehicles here? And so this helps to define the min and max ranges that then are filled with statistical data here. This leads us to the last use case, number 4, which is strongly related with ODD as a source for test scenarios, and which is the question of coverage. When are we done with testing, with simulation? When have we sufficiently covered the ODD with our scenarios? Well, scenarios are a little bit like test cases in software testing. So if you think of a Java language function, which has 2 arguments of type float, it's obviously impossible to cover all possible input values. You can select some representatives, you can select the minimum, maximum possible way, or some in the middle, or whatever, or pick them at random, but you cannot really cover everything. And it's exactly the same thing here. So scenarios just sample few representatives from a large and dense input space. First of all, it's a multi-dimensional space, so the ODD has a huge combinatorics of iterative attributes, all sorts of road types, all sorts of weather, all sorts of road markings, whatever you can have. But even worse than that, it also contains attributes from a continuous value space, like a lane width, like the visibility, whatever. So it's just impossible mathematically to pick all the values. So if you want the scenarios, so the blue lines here that I have drawn on the picture of the ODD here are infinitely thin lines. So even a large number of scenarios that you put side by side will never fully cover the surface of the ODD. So the challenge is to find a notion of sufficient coverage so that we can say in the end that the risk of overlooked hazardous scenarios is acceptably low. Well, solutions are yet to be found, but there are 2 main strategies to solve this. First one is to partition the ODD into equivalence classes and to cover them with representative scenarios. So equivalence classes could be for each road type, for each number of lanes, for each class of lane width. For example, you can partition into small, medium, and large. For each class of weather, perhaps not just sunny and rainy, but light rain, medium rain, heavy rain, a light fog, dense fog, and so on. You find representative scenarios and you permutate them. You cannot do all combinations, but you can apply strategies from software testing for finding suitable permutations. This is arguing over the ODD, and the complementary strategy comes from the other side, comes from the scenarios, and say instead of just enumerating concrete scenarios, I specify logical scenarios. These are scenarios that have still open parameters. You specify parameter ranges, but not the actual parameters, and you let the scenarios evolve differently. You can have strategies to assign parameters at random and to evaluate which gives most of the insight, and you can then recombine those where you have a lot to see and focus on these, and have less scenarios that are, let's call it, rather boring, where you have no more insights. So each scenario, see it here by the line, is just a band of scenarios. And with these bands of scenarios, you try to cover everything. These are directions of thinking, and there's a lot of activities going on here. But the final argument, the final matrix, when it's enough with testing, is still to be found. And we have, of course, risks here when doing so. One obvious risk is that we could be missing edge cases or black swans. So we have left of it and right of it, but not the thing we are interested in. Another risk is the strongly nonlinear behavior of machine learning algorithms in particular. So if you go a little bit to the right and the left, you cannot be sure that the output behavior is similar. It can be totally different. And this is different from many traditional approaches in software testing. And there is still a lot of research to do here. And therefore, we have in the OpenODD language one subgroup besides the main purpose here in the middle, which is ODD definition. We have here the red rectangle, which is about metrics. So metrics important. Metrics not only for metrics about ODDs, but also metrics about how well an ODD is covered by a set of test scenarios. To wrap up, safety, and I mean safety in a broad sense, encompassing FuSa, SOTIF, and other subdisciplines of safety, are a key property of AD functions to be accepted by the society. Everything depends on safety if you want to bring AD functions into the market. Safety processes, for example, coming from ISO 21448, require a variety of activities, and many of them are based on a stringently defined ODD or can at least profit a lot from a well-defined ODD. Examples that I have told you are specification of requirements, the design of architecture and the algorithm based on the ODD, the situation catalog for the hazard analysis based on the ODD, ODD as an important source for deriving concrete V&V scenarios for test and for simulation, and coverage metrics to enable judgment of the test completeness and residual risk after testing scenarios that are meant to eventually cover the whole ODD of an automated driving function. ASM OpenODD will provide a notation for ODDs and for related information like metrics about ODDs. That's all. Thanks for listening, and in the end you will have the opportunity to ask questions. Thank you.